Schools Initiative. These are scheduled every Wednesday through February 22nd at the same time. Several of the programs are double features, such as the two programs that you enjoy today. You're joining 83 other guests from communities, tribes, government agencies, universities, engineering, and architectural firms. Thank you for your interest in the health of our schools and our communities. I know that I introduced Matthew in the chemical cleanout, but let me do that again. Matthew Langenfeld holds a master's in chemistry from the South Dakota School of Mines and Technology. An environmental professional for 29 years, he's worked in industry and consulted with state and federal governments. He instructed college chemistry laboratory courses and has worked on school chemical cleanout and safety issues with the U.S. Environmental Protection Agency for nearly 6 years. During that time, he has helped to develop school chemical cleanout programs and examinations of issues with PCBs in Montana, Wyoming, Colorado, and South Dakota. His accomplishments include the cleanout of 123,000 pounds of toxic chemicals from 267. 88 of those are in Indian country, making schools safer for 96,000 students. So before Matthew gives you the answers, let's see if we can get these polls to come up just right, and we're going to do our best this time. Let's see if you know some things already. Before he gives the answers, will you respond to the two questions by selecting and clicking on the answer that you prefer? After everyone has indicated their choices, I will share the results with you. All right, the two most common sources of PCBs in schools are, and if you'll select one or more of the following.
Carolina,
So
there's one correct answer.
Okay. Don't help him, Matthew. All right, so 80% have voted, and the voting is beginning to slow down. So we'll 88%, good. We know that some people don't have access to the mouse, so we'll close the poll and share the results. So the most common sources of PCBs in schools are, it's kind of a dispersed number. Some people say caulk and light ballasts. Others are saying the next highest is flooring and ceiling materials. So we'll see what Matthew has to tell us as the session goes on. All right. So we put this one up earlier unintentionally, but let me at least share the results with you on this one. Children and adults can be exposed to harmful levels of PCBs in schools, and even before we attended the session, people said 100% true. Thank you very much. Okay. All right, thank you for testing what you know about PCBs in ballasts and caulk. Let's welcome now our speaker on the topic, Matthew Langenfeld.
Thank you, Carolina. Okay, so our goal is to make you aware of the potential dangers and some of the proactive things you can do related to polychlorinated biphenyls that may be in your school. So, do we know all the places where PCBs could be in our schools, and do we know what to do about that? It looks like everyone picked up on the fact that PCBs can be found in schools, and exposure to PCBs can result in health problems that may include increased risk of cancer, immune, reproductive, or nervous system difficulties. So polychlorinated biphenyls are an organic compound that is tends to be an oil. There are several different polychlorinated biphenyls, and sometimes they're mixed together in various concentrations. They can withstand high temperature, they're organic, they're chlorinated, they're man-made, and they tend to be odorless and colorless, and they have the capability of traveling long distances in the environment, and they're good for insulation and cooling, especially in electrical applications like transformers and capacitors. So again, as with other chemicals, children are more vulnerable to the dangerous effects of PCBs. PCBs can exist as a vapor in the air. They have no smell or taste. And they can also attach to particles and soil and be taken up by humans and animals. So in our present environment, on our planet, exposure to PCBs is primarily from eating contaminated fish. And the PCBs tend to bioaccumulate in the fat of the fish. And that is the primary way that humans are exposed to PCBs. And any exposure that may be anticipated in a school would be additional to that. So PCBs get into the food chain and they bioaccumulate. They are fat and water soluble, and the FDA has issued guidelines for consumption in fish, milk, meat, and eggs. Okay, so here's a good example of how PCBs can biomagnify in the food chain. And they can start off in the water with phytoplankton, and they can be absorbed by the phytoplankton. They are consumed by the zooplankton, and then smaller fish would consume that, and then larger fish. And each step along the way, the PCBs get concentrated more and more in the larger fish. And the orca is one of the species on the planet that would have what we would expect to be the highest concentration of PCBs. And in fact, there have been some orca that have tested and had the highest concentration of any known species on our planet. So PCBs are found in schools. They have been found in Caulk, in schools that have been renovated or built between 1950 and 1978. And PCBs can also be found in fluorescent light ballasts, manufactured before 1979. And removal and replacement can be a major and expensive undertaking. And some schools in New York have found that out and have been working on those issues. Now, fluorescent light ballasts can be considerably less expensive to dispose of, and they can be just properly disposed through the same method that we talked about in school chemical cleanout. However, the caulk can potentially be much more expensive. So here's some examples of caulk in schools that may or may not contain PCBs. It's also important to note that PCBs can migrate into the adjoining material like the concrete and the brick. So if in your school you know that you have caulk with a concentration greater than 50 parts per million, you are required to remove that material. And if the adjoining material has a concentration greater than or equal to 1 part per million, it is also required to be removed. So any materials that contain PCBs less than 50 parts per million may remain in place. It's important to know, it's important for me to communicate, or I feel it's important to let you know that you're not required to take any action if you don't know what the concentration of PCBs may be in your caulk in your school. Okay, so PCBs and caulk and other materials can be detected by laboratory test samples. And it's best to use a professional and to have them collect the samples. And it's important to know that you can't visually see the PCBs. There is no simple test. A physical sample would have to be collected, and you would have to use solid waste method 846-8082, and the cost is approximately $100. Now, that would not include the cost to hire someone to actually collect the sample and take it to the laboratory. And at this point in time, sampling and analysis is not required. So let's say you have a school and you don't believe that you have PCBs, or even if you do believe you have PCBs, there are things that you can do to reduce the exposure to school children and to adults. And that is to clean the air ducts, improve ventilation, clean frequently to reduce dust, clean surfaces with a wet or damp cloth, don't use brooms or dusters, and use vacuums with high efficiency particulate filters, or HEPA. So if you do have caulk in your school and you know it has PCBs and you decide to remove it, we do ask that you not take that caulk and leave it on the school grounds. This has on occasion happened. So moving on to fluorescent light ballasts. Removal is best done by a professional, and we do ask that you dispose of the PCBs by regulation. I do want to point out that for light ballasts, you are allowed to place the light ballasts in a landfill. However, we don't recommend that you do that. You are required to notify the landfill if you have over 10 and you decide you want to put it in that landfill. The landfill may not allow you to put it in their landfill, and the state may not allow you to put it in the landfill. And also, if you do put it in the landfill, you may be subject to CERCLA liability in the future if the site becomes a Superfund site. So even though there are some exemptions for disposal of light ballasts, we do not recommend that you put them in a landfill. And you know, for the light ballasts, the costs are not nearly as expensive as they may be for maybe a clean out of caulk in a school. So there are other sources of PCBs in school. They may include paints, carbonless copy paper, transformers, and capacitors. And for more additional information, we've got some links up there for you to find additional information regarding caulks and PCB ballasts. And that's all I have for PCBs.
Thank you, Matthew. We'll get to your questions next, but we hope that Matthew's presentation on PCBs in ballasts and caulk has added to or refreshed your knowledge on the issue. So would you respond again to our polls? We want to see how well you've learned. So let's launch the poll. Exposure to harmful levels of PCBs in schools can harm children and adults. True or false? Whoa, they started voting even before I finished. Great for you. Really quickly. All right, so the voting is stopped. We're going to close the poll and share the results. Matthew, you did a good job, it looks like. Any comments about this one?
Well, thank you for the compliments. You know, I think everyone was pretty much well aware of that issue. They voted 100% true, I think, to begin with. So we have a pretty knowledgeable crowd.
Great, thank you. All right, let's look at the next question. The two most common sources of PCBs in schools are, and you can select one or more of the following. The votes are coming in really quickly. Still some split votes here, Matthew, so you'll have to talk about this, I think. 70% have voted. Votes slowing down. All right, I think we're going to close the poll and we'll share the results. So Matthew, any comments on the difference in the votes on this one?
Well, I think it's improved from in the beginning, which is great, and 94% gave the correct answer. And the most common source of PCBs in schools is caulk and light ballasts. You know, PCBs could probably be in almost any material, and you know, they certainly could be in you know, paint on walls and other things. But the most common thing that EPA has found is that they're in caulk and light ballasts.
Great, thank you. All right, so now we have some opportunity for some questions. And if you have some questions, of course, you can raise your hand and participate on the air. We'd love for somebody to have an on-the-air question. Oh, we have one right here. I think you sent in, I'm going to unmute you, Josilla. Do you have a question? Josilla Bear Whiteface. She also asked one in the question box, so it may be that she took care of it that way. Anyone else would like to ask a question of Matthew on or off the air? All right, here's the question for you. I have some specific questions about the demolition in and around suspected PCBs in an old sawmill. Can I somehow contact Matthew to discuss this a little more in depth? I have had a Phase 2 site assessment and Phase 1 completed on the site. PCBs were detected in the groundwater. Demolition is occurring without my approval, which is partly due to tribal authority, etc. So Matthew, Jolissa has that question.
Hi, Jolissa. Thank you for your question. And, you know, I would be happy to talk to you about that, you know, outside of this presentation. You know, we're trying to focus on schools, so why don't you give me a call? I think you've got my contact information there, and we can talk about it from there. Great.
Another question for you, Matthew. How can a school address challenges in funding a PCB cleanup?
Well, that can be difficult, and you know, if you know you have PCBs in your school and you know that they're over 50 parts per million, then you are required to clean that up. And that can be a difficult thing to find those cleanup funds, but there may be a possibility if the school is being closed, there may be some brownfield funds. So again, cleanup can be kind of a difficult circumstance, so I would recommend you give me a call and we can talk about it from there.
All right, and Matthew's telephone number is on the screen. Another question for you, or another comment. I've attended other webinars regarding this topic. Does funding for remediating light ballasts, such as Energy Star, apply to tribal schools?
I don't believe that there is any funding from Energy Star for disposal of light ballasts.
All right. Short question, short answer. We're sorry. That would like to see that make it possible for you. And that was Makia who asked that question. Chris asks, do the federal regulations require testing of window caulk?
At present, it is not required to test window caulk for PCBs.
All right. Anyone else have a question? You can raise your hand and speak to Matthew on the air, or you can send in a question in the question box. Well, Matthew, it looks like that people are writing down your phone number, and we'll get in touch with you separately. So we'll close the webinar, but let me just remind you or let you know that we're going to be hosting a workshop. Our Clean, Green, and Healthy Tribal Schools Initiative will be sponsoring a 2-day workshop in June or July this year. The workshop will include some of the programs that have been featured in the series and additional topics as well. Participants will have the opportunities at that time for discussion and collaboration with the presenters and their co-participants in person. Please let us know if you might be interested in attending. Remember that at the end of the webinar, you'll be receiving a few survey questions. Please take the 45 or 50 seconds that it will require to respond to those so that we'll know what your interests and intentions are and how we can best serve you. Again, thank you very much for attending the webinar. We'll be on for just a few minutes if anybody else has a question, but otherwise the webinar is closed for today. We look forward, hopefully, to seeing you next Wednesday at the very same time for the webinar on asbestos awareness and the RRP, or the Renovation and Repair Painting Rule. Thank you very much.